Hi everyone, in this video I am going to teach you on how to convert repeating decimal into fraction. I have four cases here, and in each case there are three examples, so please bear with me. Let's go to case number one. In case number one, as you can see in the three examples, the ones digit is 0. So for example number one, there's only one repeating decimal digit. If that is the case, then we can simply take away that decimal point and the 0 and then divide it by 9. So for example number 2, we have two repeating digits here, which are 4 and 5. Again, you take away the 0 and then the decimal point. So it's just 45 over 99 because there are two repeating decimals. Oh, this is not the final answer, by the way. We need to simplify this. 45 and 99 are both divisible by 9. So we can simplify this as 5 over 11. So with my third example, there are three repeating digits here, 126. So if you follow the pattern, this is just 126 over 999. And again, both 126 and 999 are divisible by 9. So that means we can simplify this. 14 over 11, 111. So you can actually check your calculator if my answers here are correct. All right, let's go to case number 2 now. So for case number 2, the ones digit is greater than 0. So here we have 2, we have 3, and then we have 7. All right, so let's go to example number 1 first. Okay, so for this one, we will just remove the decimal point. We consider that 23 minus the ones digit, which is 2. So this gives us 21. Since there's one repeating digit, which is 3, so this is just 21 over 9. And again, 21 over 9 can be simplified. That's 7 over 3. So that's the final answer. Again, you can check your calculator if you want. All right, let's go to the second example. Again, we take away the decimal point. So it is 3, 4, 5 minus the ones digit, which is 3. So this is 342 over, since there are two repeating digits, this is 342 over 99. And of course, we can simplify that because both are divisible by 9. So the answer, or the simplified form rather, is 38 over 11. All right, for my last example in case number 2, again, we just take away that decimal point. So you have 7123 minus the ones digit, which is 7, and that gives us 7116. All over, since there are three repeating digits, that's 999. All right. And again, we need to simplify that because they are both divisible by 3. So talking about the numerator and the denominator. So 2372 over 333. All right, let's go to case number 3 now. So in case number 3, the ones digit is 0. And then after that, there are some numbers or digits that are not repeating together with the repeating digits. So for example, in number 1, we have zero point 0.5 and the repeating digits are 1, 2. So how are we going to solve this? Just like what we did in case number 2, we just take away that decimal point. So that's 512 and then subtract the non-repeating digit, which is 5. Okay, so this is 507. Now since there are two repeating digits, that's 99, and there is one non-repeating digit, that'll be 0. Okay, so let's simplify that. I think we can simplify that. So 500 7 divided by 990 is equal to 169 over 330. Okay, I will write it down. All right, for my next example, again, we consider removing that decimal point. So that's 143 minus the digits that are non-repeating, and those digits are 143. We subtract those two, that would be equal to 1289. Alright, so watch this. There's only one repeating digit, which is 9. The three other digits are non-repeating, so 0, 0, 0. Okay, now let's check if we can simplify that. Alright, I think that's it. So let me just encircle that. For my last example here, we have 7813 minus the non-repeating digits 78, and that would be 7735. The repeating digits are 2, so 99. The non-repeating digits are 2, so 0, 0. And I believe this is the final answer. Alrighty. Alright, let's go to the last case, case number 4. Here, this is a combination of case 2 and 3. So the ones digit is given, and there's actually a tens digit in example number 2. And then there's an after the decimal point, there is a non-repeating digit. So how are we going to answer this kind of question? Alright, let's consider the example number 1. Again, you take away that decimal point. So this is 2314 minus, okay, the non-repeating digits, 223. So this is equal to 2291 over how many repeating digits? 2. How many non-repeating digit after the decimal point? 1, so that's 10. And that will be the final answer. Again, you can actually check that using your calculator, and you will see that it's 2.314141414. All right, let's consider example number 2. Again, we take away that decimal point. So 13527 minus the non-repeating digits 1352, right? Which is equal to 12175 over how many repeating digits? We have 1. How many repeating non-repeating digits after the decimal point? There are 2, so 0, 0. I believe we can simplify that. They are both divisible by obviously 25. So 12175 over 900 is the same as 487 over 36. Alright, in my last example, you can actually pause the video and try to answer this one if you want. Alright, so let's answer number 3 now. 8423 minus the non-repeating digits 84, and that equals 8339 over, there are 2 repeating digits 99. There's 1 non-repeating digit after the decimal point, so that is 0. Okay, let's check. Alright, I think that will be the final answer. Alright, so I hope you learned something from this video. If you like it, please like this video and do subscribe to my YouTube channel. Thank you and have a nice day. Bye-bye.